Okay, example. So VxWorks is a real-time operating system. MACourina is a real-time operating system. If the operating system's execution time is 100% predictable, then we can say that operating system is real-time operating system. What about Windows operating system? Is it real-time operating system? Execution time of the Windows operating system is not predictable because when we open MS Office, maybe when we open the PowerPoint presentation, exactly we cannot say within 2 seconds PowerPoint will open, 5 seconds PowerPoint will open. So it will open sometime, and sometimes there will be a fan clock which comes and something will rotate. So whenever rotating means you are not able to predict when it will open. So Windows is not a real-time operating system and need not be. Missile airline is tolerable here, so it is not necessary to have a real-time operating system for a desktop system. Hence, Windows is not designed for that. But there are some applications where missing deadline is tolerable. Something like our rocket propulsion and biomedical application. We are very eager to talk about what is real-time signal processing. If the execution of the signal processing is 100% predictable, then we can say it is real-time signal processing. That is what we used to say. Okay, so the output follows the input without storing and playback, without storage and playback, then it is called as real-time signal processing. Okay, so very good example is switching on the front camera and then smiling in front of the front camera. The screen is also smiling, which is a good example for real-time signal processing. In one context, we can say real-time signal processing needs no memory. Very good example is whenever you switch on the front camera, when you smile, it smiles. When you look at somewhere, the input goes to the camera, the output comes to the screen. Just like that, it is something like a input going in and processing, and output comes. No nothing is being stored. Because it is real-time signal processing, quickly it is going inside the camera, it is quickly coming out from the screen. Something like that. It's for real-time signal processing, do not need memory. I'll justify with some example, which is more interesting. Is our TV. TV is a good example where in our TV there is no memory. You must agree that, right? Our TV do not have any memory. If there is no memory in the TV, then what happens? Whenever the Sun TV or Vijay TV or Star TV or whichever TV broadcasts, then only we can able to see the audio, video, etc. If they stop broadcasting, nothing will come in the screen because there is no memory in our television receiver. So that is real time. So if they broadcast at this moment, now we are able to see the video. When they stop the broadcasting, you will never see the video. That is the magic here. So television receivers are a good example for understanding real-time video. And real-time signal processing do not need memory. Very good example is our television receiver. And similarly, our radio receivers. We are able to hear. That's all. Whenever the broadcast, we can able to hear. Whenever they are not broadcasting, we are not able to hear. Nothing is there in the radio to store anything. A good example is Google Meet. So now we are doing the Google Meet. Some recording is on. That is why it is recording. If the recording is not on, all of us are able to see something in your screen. Nothing is stored in your mobile. But there are 32 of us are here. 32 screens are having the same slides. 32 loudspeakers are processing the same voice signal. And the chat box, every 32 of us are seeing all the messages in the chat box. But nothing is being stored anywhere. So whenever the class is over, everything will disappear on the screen. So if you are not recording, nothing is being stored. It is something like watching TV. Okay, so very interesting, which is real-time multimedia signal processing. And TV is a real-time multimedia signal processing. And radio receiver is real-time audio signal processing. And voice call, whenever we call to each other, then it is real-time speech signal processing. So earlier we have seen multimedia signal processing, audio signal processing, and speech signal processing. Here we are repeating the same. Real-time multimedia signal processing, real-time multimedia audio signal processing, real-time speech signal processing, which is so interesting, which is very interesting. Okay. Now the curiosity comes into picture. This real-time is possible only when you satisfy Nyquist sampling theorem. Here also Fs is greater than 2Fm comes into picture. That is the beauty we have to celebrate from the signals in system. Okay. Great, very nice. Again, few examples here. So viewing TV and cable TV or direct to home is a good example for real-time multimedia signal processing. The conversation in mobile phone is a good example for real-time speech signal processing. Listening to FM is a real-time audio signal processing. Attending the online class in the Google Classroom or Microsoft Teams or Zoom, etc. is a good example for real-time multimedia signal processing. Caller mic is a good example for real-time signal processing. Now I'm coming to the chat box to ask few questions. Coming to the chat box, what is the frequency of the voice signal? ஒரு ஹியூமன் பீயிங் பேசுறாருன்னா அவர் நீங்க ஒரு மைக்ரோஃபோன் வச்சு மைக்ரோஃபோன் அவுட்புட் எடுத்து ஒரு சிஆர்ஓல கொடுத்து சிஆர்ஓல எவ்வளவு ஃப்ரீக்வன்சி மெஷர் பண்ணா என்ன வரும்ங்கிறது கேள்வி. It is not human voice will never go up to 20 kilohertz. Human ear can hear up to 20 kilohertz. So every human being in the world can produce maximum 3.3 kilohertz. So beyond 3.3 kilohertz, no human being in the world can produce the sound. This is the analysis. It's very interesting and very important. Okay, so all human beings can produce only maximum 3.3 kilohertz, maybe from 20 hertz to 3.3 kilohertz. So exactly speaking, the girl's voice are having higher frequency when compared to boy's voice. Their low frequency means skin instruments, something like that, skin instruments as we are discussing. So what? It will be a bass voice. Boys means what? Boys are male means what? Something like that. Bass voice will come. Whenever girls are speaking means there will be a frequency will be high. So we can differentiate the male voice from the female voice from the frequency. So always the female voice frequency is greater than the male voice frequency is the simple analysis that we need to understand, which is very important and very interesting. Okay. So that is the idea we need to have. So every human being can produce only 3.3 kilohertz. So that means if your microphone is there and this is FM, maximum frequency FM. And for our NICO sampling theorem, we have used NICO sampling theorem for reconstructing it in the real time. That is what our next interesting topic. Let us go to that and let us analyze this, which is very interesting, right? Okay, so coming to the screen. So collar mic is a good example for real-time speech signal processing. Sampling theorem, Fs is greater than 2fm must be followed for the real-time speech signal processing. So what is the frequency of the speech signal? So all human beings, maximum voice frequency is up to 3.3 kilohertz, which is approximated as 4 kilohertz, where fm equal to 4 kilohertz. So according to the NICO sampling theorem, the sampling frequency voice signal should be twice that of the maximum input signal. So maximum signal is 3.3, which is approximated as 4. Hence, your sampling frequency should be 8 kilohertz. So Fs is 8 kilohertz. What do you understand from this? We needed to take 8,000 samples per second. It has to be converted to the digital signal x of n using ADC, which is coder of your codec. Okay. Then all the 8,000 samples need to be convolved with the digital filter coefficients h of n to produce y of n. Okay. So here x of n is 8,000. H of n is our filter coefficient. And y of n means 8,000 plus h of n is 50th order filter means 8,050. And n1 is 8,000, n2 is 50. So 8,050 minus 1, 8,049 y of n samples will come. This y of n samples has to be given to the digital to analog converter to convert it into analog, which is y of t through codec. Then it should be given to the loudspeaker to reconstruct the amplified or filtered voice signal. That you need to understand. So 8,000 x of n's are there. We need not wait until 8,000 x of n's. So 8,000 are converted into 100 samples means that is called a segmented convolution, where you go for overlap add and overlap save method. In your DSP lab, you are doing that. This is so beautiful, right? Like x of n is lengthier sequence. Hence we go for segmented convolution. So it's another example. Every second from my microphone, we are supposed to take 8,000 samples per second. All the 8,000 samples cannot be convolved just like that. So we have to segment it into, for example, 100. So 100 x1 of n is 100. Convolve with h of n. You will get y1 of n given to the loudspeaker. x2 of n. Convolve with h of n. You will get y2 of n given to the loudspeaker. Something like this. We are segmenting the lengthier x of n into x1, x2, x3, x4, and we are doing the segmented convolution, which you call it as overlap pattern, overlap save method, which is so beautiful and so interesting. Okay, so this is how we have to work. So 8,000 convolution, 8,000 multiplications has to be done, and 8,000 addition has to be done, and to perform this convolution in 1 second, then only 1 second voice will be reconstructed more beautifully in the loudspeaker. That is very interesting. But when you look at the audio signal, because audio signal is up to 20 kilohertz, so FM is 20 kilohertz means, and the sampling frequency should be 40 kilohertz. Okay, but the international standard is 44,100 hertz or 44.1 kilohertz. Okay, so 44,100 samples need to be processed in 1 second, reconstruct 1 second audio. Now you can understand the significance of speech signal processing and audio signal processing. It is very important for all of you. Why we are differentiating or classifying speech signal processing and audio signal processing, here you need to understand. When you talk about speech signal processing, the sampling frequency is only 8 kilohertz. When you talk about audio signal processing, sampling frequency is 44,100 samples per second, which is 5 times greater than the speech signal processing. Hence, audio signal processing is 5 times complex than the speech signal processing. That's why people are segmenting into speech signal processing, where the sampling frequency is only 8,000 samples per second or 8 kilohertz, where the audio signal processing you need to take 44,000 samples. This is very important because this is standardized globally. In India, in Reliance, it's not like that. Whenever you take a microphone, whenever you say hello, anywhere in the world, it takes only 8,000 samples per second. If it is speech, if it is an audio, it will take 44,100 samples per second. So then it can reconstruct up to 20,000 hertz. So beautiful and so interesting. This you need to understand. Now you got the idea where what is speech signal processing and what is audio signal processing. Okay. So that's great. With that understanding, you can see this diagram, which is so beautiful. So there is a microphone. We are speaking here, and there is a signal conditioning, which is something like amplification and attenuating, etc. Anti-aliasing filter means f is greater than 2 that you are ensuring here. That means you are taking ensuring here. That means we are anti-aliasing filter means what? Frequencies above 4 kilohertz will be attenuated, because whenever we are doing speech signal processing, 5 kilohertz signal is a noise, because 4 kilohertz is the maximum FM. So the 4 kilohertz low pass filter is anti-aliasing filter. This you need to understand. Very simple, because human voice will never exceed 3.3 kilohertz. So any signal from the microphone beyond 3.3 kilohertz is only noise, so which has to be attenuated before processing. And there is something like low pass filter with some 4 kilohertz of cutoff frequency is called as anti-aliasing filter. If so, only the speech signal will go to the analog to digital converter, and the converted digital data is processed by using digital signal processor, and we will get Y of M, which is again 11100 something, and again digital to analog converter, the analog values, then again smoothing filter, then again it is given to the loudspeaker. So this and all you know very well. So interesting and so beautiful. This is how you need to understand. Okay, now challenges and solutions in real-time signal processing. Challenges and solutions in real-time speech signal processing. What is the challenge here? The processing element inside the processor is the ALU. The basic building block of ALU is full adder. Hence, ALU performs the multiplication by repeated addition. If so, consider the signal processing example where x of n is 16-bit value and h of n is also 16-bit value. If so, unsigned maximum 16-bit value is h of n equal to 0x FFFF, and x of n is also 0x FFFF. If so, for performing convolution, first x of n need to be multiplied with h of n, that is 65,535 need to be multiplied with 65,535. For that, what to be done? Do this multiplication. 65,535 is added with 65,535, 65,535 times. So if every addition takes 1 microsecond, then one 16-bit multiplication takes 65,535 microsecond. For 8,000 such multiplications, 8,000 into 65,535 microsecond equal to 520 seconds approximately. You have to process 1 second speech signal. It takes more than 8 minutes by 16-bit microprocessors or controllers. This is challenge number 1. ஐயா ஹலோ அப்படினால 8 நிமிஷம் கழிச்சு தாங்க வெளியே வருது, என்னங்க பண்றது? பார்க்கலாம் என்ன ஆன்சர்னு பார்த்துருவோமா? So MAC is nothing but hardware multiplication and accumulation unit. So the presence of MACourina inside the architecture can do signal processing. Vijay என்ன சொல்றாரு? So this is the beauty of learning through the song. So hardware multiplication and accumulation do the sum of product. or convolution, or we call it as signal processing in real time. The processing element inside the digital signal processor should do the convolution, sum of product in real time. We have to go for hardware multiplier. So the processing element inside the digital signal processor is hardware multiplier. So the presence of hardware multiplier can do signal processing. But for 8,000 multiplication means 8,000 products need to be added 7,999 times. Adder should also be hardware. So there is a need for a hardware multiplier and hardware adder. So the presence of hardware multiplier and adder can do signal processing. We have a 17 cross 17 bit hardware multiplier. There is a separate hardware multiplier and there is an adder. There is a 40-bit adder. So the presence of this hardware multiplier and adder, in short, this box is called as MAC unit. So presence of this MAC unit, in short, presence of MACourina can do signal processing so beautifully. So that is the moral of the story. Keep hardware Mac and close that microcontroller. Now you can say this microcontroller can do signal processing.